उषा मैम, उषा मैम, उषा मैम, आप मेरी आवाज सुन पा रहे हैं? मैम, काइंडली स्टार्ट द प्रोग्राम.
हो गया? ठीक है, तो
प्लीज स्टार्ट. यस मैम.
ओके ओके ठीक है. नमस्ते एवरीवन. यथा शिखा मयूराणां नागानां मण्यो यथा तद्वत् वेदांग शास्त्राणां गणितं मूर्धनि स्थितम्. Means like the crowning crest of the peacock and the shining gem on the head of the cobra, mathematics is the supreme head of all sciences and knowledge. A very good morning and thank you all for joining us in today's webinar. This is Usha Arora from Department of Mathematics, Deshbandhu College, taking the privilege to welcome you all in this webinar on Introduction to Wolfram Mathematica, being organized by the department and IQAC Deshbandhu College under the aegis of Kshitij Mathematics Lecture Series, being initiated by our dear principal and eminent mathematician, Professor Rajiv Agarwal. Our sincere gratitude to you, sir, and to our teacher in charge, Mr. Chandrasekhar, for taking all the efforts and executing this event so well. So, as a mark of our undying tradition to start any academic event, we start with a prayer to Ma Saraswati, the goddess of knowledge, learning, and intellect. Please join us with the prayer to Ma Saraswati. So, let's join with the prayer. What a divine feeling we have. Now I request our dear principal, Dr. Rajiv Agarwal, for the formal welcome address. Over to you, sir, for the address.
Thank you, Usha ji. A very good morning and namaskar. On behalf of Deshbandhu College, I welcome all the participants of this webinar on Mathematica and the resource person, Dr. Bisht, for accepting our offer to deliver a talk on Mathematica. Friends, the computer algebra systems, whether it is Mathematica or other algebra systems, MATLAB, MathCAD or others, they have become very important, and rather I can say the mathematics, the numerical analysis, it has become almost impossible to do research or to do computation without assuming that we are not having computer algebra system. Now, I share you an incidence like when I was doing research in the year 2001, when I started my PhD, it took almost 1 year to do manual calculations. Of course, they were very lengthy calculations, but when I came to know about mathematics, I learned mathematics. It took almost 3 or 4 months to learn that the calculations which I did. Hey, just a minute. Sir, आपको 2 मिनट में कॉल करता हूँ, एक सेमिनार है. The calculations which took almost more than a year, I was able to compute all those calculations within a span of 3 days. So that time, the Mathematica or other computer algebra systems were very newer. That's why it took so much time to learn and other things. We are fortunate today that our college have bought license for Mathematica. Our students are learning Mathematica. Our teachers are learning Mathematica. And we all can say that it is almost impossible now if we don't learn mathematics, Mathematica software. We all can see that visualization of graphs, computing differential equations, whether it is symbolic or numerical, they have become so easier that we can say it's like peanuts now. So my best wishes, congratulations to the mathematics department, to our students, Mathematics Student Society, Kshitiz, for organizing this important webinar. I hope that all of us will be benefited by this. And I suggest also that there may be more sessions of Mathematica. So I'll request Dr. Bisht to have 2 or 3 more workshops. We should incorporate parallel computing as well, cloud computing as well in the further future seminars of Mathematica as well. I congratulate Dr. Usha, Dr. Chandrasekhar Azad, the whole mathematics department, our young and old faculty, Dr. Harindri, our IQAC coordinator, Dr. Aditya, for organizing this. My best wishes for this webinar. Thank you.
Thank you, sir, for your inspiring and really thought-provoking words. So before we get started, just a little bit of housekeeping. If you have any questions, you can drop them in the chat window. Our moderator, Rohit Goyal, our colleagues from the department, Rohit Goyal will take the questions from Zoom platform, and Ms. Parveen Bawa, she'll be taking questions from YouTube. A recorded version of the event will be available at the Deshbandhu YouTube channel. It is being live streaming on YouTube also. Next item is now the introduction to the guest of today. Mathematics is a system for doing mathematics by computer. Mathematica is a system for doing mathematics by computer is the catchy title of the book by Stephen Wolfram, the creator of Mathematica. We know one quotation, very catchy quotation, which says that how can we apply practical versus theory? It says, knowledge is not enough, we must apply. Willing is not enough, we must do. So we should do all the things, all the questions as we are taking, my colleagues are also taking in the practical classes, all the questions with the help of Mathematica. We are doing modeling, many other practicals we are taking, but still we lack many things. So today we are honored to have among us our presenter, Mr. Mahendra Singh Bisht, an expert on Mathematica. It's my honor to introduce Mr. Mahendra Singh Bisht. Mr. Bisht is system engineer at Cube Scientific Software Private Limited, New Delhi, joined the company in 2016 and has been associated with Wolfram Mathematica since then. BTech in Electrical and Electronics Engineering, Mr. Bisht is a certified RHEL engineer and administrator, having programming experience with Wolfram language, C, C++, and SQL. He has conducted many workshops on Mathematica in various research institutes and universities across India. Areas of his interest are parallel computation, modeling, simulation, and interactive visualization. A great admirer of Wolfram Alpha, the computational search engine, he enjoys the working of this engine, especially how it uses algorithms to provide step-by-step solutions to mathematical queries. So let's explore Mathematica with our subject expert on Mathematica, our Mr. Mahendra Singh Bash, and learn so many things about Mathematica and grid Mathematica and many more disciplines. So over to you, sir. Mr. Mahendra Singh Bash, it's your time now.
Okay, yeah, so I guess I'm loud and clear to all of you.
Yeah, you are audible, sir.
Okay, so let me just share my screen first. Okay, so first of all, thank you for the introduction. Okay, and hello everyone. Myself, Mahendra Singh Bist, and in today's session, we are actually going to see the mathematical capabilities, right? We are just going to talk about like what are the features in Mathematica, how you can do programming in Mathematica, and how you can design your own functions in Mathematica. To minimize this one. So during this session, if you have any queries, you can put it under chat box. I guess all of you are muted. So yeah, you can simply put your question in the chat box. Right. So we can start now. So the first thing that we have is what is Mathematica, right? So the Mathematica is basically a symbolic numeric computational program, right? It's basically a computation program which can do both as symbolic as well as numeric tasks. It can deal with equations symbolically and numerically also. And this engine is basically used in many fields, especially in computing fields. Okay, so people use Mathematica to solving their coursework related problems. They also use this Mathematica to do their research work related queries. Okay, the same platform is also used for like teaching purpose, like many colleges and universities are basically using it for teaching mathematics, physics, means anything which has computation. Okay, so the engine is basically knowledge base engine, which means it can perform a lot of tasks. Okay, there are many built-in functions in Mathematica which you can use to do a lot of things, like you can solve equations in the sense it can take algebraic equations, it can also take transcendental equations. uh, this platform can also be used for doing programming in the sense like it supports multiple paradigm, like functional, there is procedural, then there is rule-based, conditional, okay, recursive programming, and there is also pattern match programming. Okay, so it supports multiple programming paradigm, right? Then it has like it supports multi-data formats. If you just check,
Mahendra sir,
yes,
your audio is not clear. Please rectify it.
okay, so is it audible now?
Yes sir, yes sir.
Okay, fine. So the Mathematica has a more like it has a multi-data formats. You can use, means if you're working on certain data format, And if Mathematica basically supports that particular format, you can import that data in your Mathematica file, do the required computation on it, and once you have got the output, then you can export it to some other format also, right? So it totally depends upon the format that you're working on, whether Mathematica supports it or not. I guess in this latest version, it is around the import format is something around 200 and 200 plus something. Okay. And most of the people, they work with like CSV file, Excel file, MAT, okay, and TeX file. So if you're working on such files, you can directly import them in Mathematica and start working with it. Okay, so the engine is also used for like visualization function. I've been working with this computational software, not this only, because I've worked with many computational programs at different levels, and I have seen like Mathematica, this is one of the like powerhouse of Mathematica, especially like visualization functions and data. Okay, it is not only just limited to function visualization. If you're working on data, you can also import data in Mathematica, do a visual on top of it, and you can export that result over like any other platform. You can also export it to web also, right? So Mathematica is designed by Wolfram Research. Wolfram Research is the what do you say, is the main company. Wolfram Research designed many products like Mathematica, then there is Wolfram Alpha, then there is a Wolfram System Modeler, something which is related to like system level designing. It also designed like Mathematica Cloud. So nowadays, most of the people are switching to Mathematica Cloud, as you can access Mathematica Cloud just from a browser. You just need a browser cloud account. If you have those things, then you can directly access those cloud facilities, right? So all these products are basically designed by Wolfram Research. So in this session, we are just going to cover most of the part of Mathematica, then some part of Wolfram Alpha, right? So if you can see here, like its initial release was in June 23, 1988, which means more like 30 plus years of R&D has already been done on this software. And the current release is 12.1.1. The version that I am using, it's basically 12.0. 12.1 was released like last week. Okay, so you can find like with every Mathematica release, like there will be minor release, there will be like a major release. Okay, so in minor release, they basically add like more font, or like they add some new methods. Okay, a fully function incorporation like usually happens when it goes through a like major release or major revision when happens. I assume you all can see my Mathematica screen. So in this slide, this is basically a code. We are basically solving in this code. What we are trying to achieve, we are basically solving a two what's the second order partial differential equations. This is our PD equation here, right? And we are solving this PD equation which is governed by a certain set of, let's say, non-linearities. You can see this parameter A, B, C, D. These are basically non-linearities defining this PD. Okay. Similarly, this PD has some boundary conditions which is mentioned in here. So in this particular code, what we're trying to achieve, we are basically solving a second order PD equation in Mathematica, which has nonlinearities, right? And the PD is, and we are giving some starting condition in here. Then we are using certain methods to solve that PD equation. Okay, so the best part with this code is that, you see, this code is basically going to give me a dynamic result. If you can see here, I have defined some ranges for A, B, C, D. So these non-linearities can be anything, and I have defined a set like I have given a manual range to this non-linearity. If you are getting like field data, you can directly forward it to this such type of codes, okay, and it can give you such result. Okay, so long story short, in this PD, what we are trying to achieve, we are solving a second order PD equation which has certain non-linearities. We are also using certain methods to solve it. So once you try to solve such partial differential equation in Mathematica, we basically get a dynamic model like this one. So as you can see, this PD is basically resembles the effect of tsunami on a nearby landscape. Okay, and the parameter here like A, B, C, D, these parameters are basically like, we can say like these are physical parameters. Okay, it can be like temperature, buoyancy, viscosity, and because they are going to change. Okay, so what we're producing here, we are solving a partial differential equation with nonlinearity, and we are running it over a certain set of nonlinearity range, and using Mathematica inbuilt functions. You see, these all the functions which are appearing black in color. These are basically Mathematica inbuilt functions. We're using these functions to give us a dynamic result. Dynamic in the sense, if we just change any of this physical parameter value, my model is going to behave accordingly. So yeah, as I have told you, like visualization functions or producing dynamic models are like one of the powerhouse of Mathematica. Okay, you can take this example as like if you are running such codes on a server, and if you're getting this field data, okay, uh, like somewhere tsunami is happening, and you're getting this field data, you can directly put that field data onto your models, and you can basically, it can show you like what is happening in the nearby landscape where tsunami hit. So producing such powerful models in Mathematica is quite easy. You just need to know like certain Mathematica syntax. You just need to know like how to use Mathematica inbuilt function to produce such results. So next we have is the features. So these are some salient features of Mathematica version 12.0. It also includes 12.1.1. Okay. So the first one is like Wolfram Alpha integration. This is computational search engine. This is also one of the products designed by Wolfram Research. Then we have like core algorithms. Core algorithm in the sense you use Mathematica inbuilt functions like solve, desolve, and desolve. Okay, so basically those functions are running on some already established methods. Okay, they're running on already established like mathematical methods. Okay, so core algorithms has like collection of all those methods. And then the 2D and 3-dimension graphics, where this engine can do not only like 2D graphics, it can also produce 3-dimensional graphics. Then there is like probability and statistics, financial engineering, image processing. It has like feature detection, geometric transformation, and there's perspective transformation, segmentation analysis, and there's like nice webcam support. So webcam support in the sense like if you have any image acquisition devices connected to your machine, so with Mathematica code you can basically access that device. You can write code like find faces, so it will detect the people's sitting or like people in front of your image acquisition devices. Then we have like control systems, wavelet analysis. This particular field is heavily used for like signal filtering, graphs and networks, then the programming and development where it supports like multiple programming paradigm. Similarly, as this is basically a hybrid engine, which means it can also communicate with other languages. So if you are like, if you have already a code which is built on like C, C++, or any other languages, okay, so you can call them from Mathematica. That facility is available with this Mathematica engine. It also supports like CPU-based parallelization, and there is GPU support is also there. So CPU-based parallelization is like whenever you launch Mathematica code, they are basically designed to run on just a single core. Okay, if you want to use more hardware resources or more hardware available resources, basically, okay, then you can basically say apply this parallel computing in Mathematica. Then it also supports like GPU support. So if you have like NVIDIA card or any GPU graphics card, okay, just first check whether your Mathematica supports that card or not. If it supports that card, then you can write certain codes, call some packages which produce certain libraries by which you can basically put your code on your GPU machines. Okay, so so these are the some features of Mathematica, and in this session we are not going to cover all of this, okay, because we will just cover like some syntax part and how to do mathematics with Mathematica. That is our like main emphasis on this session here. So as we are saying that this one is basically a symbolic and numeric engine, which means in case of symbolic, it covers like some limit, generation of series, derivatives, or integrals where it can be like definite, indefinite, or multi-integrals. Solve where it can deal with equations like algebraic or transcendental equations, okay, or getting and optimize equations, okay. Similarly, it has functions which can deal with differential equations, and Mathematica is also a collection of many special functions, right? So when we talk about like symbolic engine or like numeric engine, we use many functions. As I've told you, like it has over 5,000 plus of inbuilt functions. Okay, so you can use those functions to solve your course related problem. Okay, you can also design your own functions in Mathematica. Next we have is the numerical engine. So in case of this numeric part, it covers optimization, image processing. This is some like bifurcation diagram, and this one is a beautiful orange attractor. It is also like probability and statistics here. Okay. So once you get the Mathematica software with you, like if you go to Mathematica website and you apply for a trial license, or if you purchase one, you get basically Mathematica software for like Windows, Linux, and Macintosh. Okay, and these softwares are quite heavy. So right now their size is like around 4+ GB. Okay, so and this software is all these packages, means I will not say packages, basically it is functions which can deal with queries related to these fields. Okay, so in case of Mathematica, we don't need to, let's say, add any other toolbar or add more packages. Yeah, there is a facility where you can add more advanced packages. Okay, like here there is a palette, you can add package from here. But if you just go with the general Mathematica startup, in that case, you get a single copy, which is all these functions, like all these functions which cover all this area. Okay, so as definition state, like it is used in like scientific, engineering, mathematical, computing fields, and people are using it for doing a broad range of tasks. Okay, with over like 5,000 plus of built-in function, like people usually ask me like how we can start with Mathematica. So I will just state that like there is no point studying like all those 5,000 plus of built-in function. Okay, if you're not going to use it, then there is no point studying all those functions. Okay, you just need to remember the syntax and the relevant functions which is related to your queries. Okay, so in the next slide we are going to cover that part. Okay, next we have is the Wolfram alpha. Okay, before we start with Mathematica syntax, I just need to cover this one. Okay, so the first one is like Wolfram Alpha. Wolfram Alpha is another product designed by Wolfram Research, and the Wolfram Alpha is basically a computational search engine, right? Computational search engine in the sense, right? We have Google, then we have Yahoo, then Bing. These are all basically search engine. If you just like, if you ask any mathematical query, or if you just put any mathematical query to give it to Google, Google engine is not designed in a way by which they basically tries to solve that query. Okay, so if you simply ask like integrate some function, then Google engine it doesn't even try to solve that equation. It basically searches that particular phrase. It does first. It does the semantic interpretation. Once this is done, then it basically search that particular phrase across the web pages, and it will try to give you the best possible result that it can fetch. This is how Google and other engines work. Okay, and but Alpha is somewhat different. It is basically a computational search engine, which means if I put any query, or if I give any query to my Alpha engine, then it is going to solve that query using the established mathematical methods available to it. So this is like the major difference between Alpha and Google. Google search it across web pages. Alpha, it just tries to solve that query. Okay, so you can basically access Alpha from a Mathematica notebook also, and you can also do it from a browser. Okay, so once you get Mathematica setup, which is around 4 plus GB, you download it, then install it. You open Mathematica. Once you start working with Mathematica, you open an interface. This is basically a notebook. It is known as Notebook in Mathematica with an extension .nb. Okay, so Mathematica software has basically two components. One is Mathematica, second is the kernel. So this one that I'm showing you all is basically the Mathematica GUI interface. Okay, means graphical user interface. It has like lots of functions by which you can access Mathematica kernel. It has also lots of like help menu available in this interface. You can see here in top menu there are like many functions like file, edit, insert. Then there is like many formatting style sheet available in Mathematica. Cell graphics, evaluation, where you can also let's say configure your kernel configuration. Then there is palettes where it has basic math assistant, classroom assistant, uh, and then there is like you can create like slideshow, or you can make it like a working notebook also. Then you can also install palette from here. Okay, so like you can see there are so many things, like so many options available in the Mathematica GUI interface, right? So when you launch Mathematica, it basically opens a GUI interface that you are that basically I'm sharing you right now. So this is basically GUI engine, GUI interface. Okay, whatever things I do here means whatever query I put here, they are basically going to Mathematica just collect all those things. It basically going to dump it onto the kernel. So if you are very let's say if you're very easy, or if you feel very easy or convenient with Mathematica syntax, then you can also directly start working with your kernel. Okay, because like I have seen people who knows their mathematical code, so they directly start working with the kernel. So kernel is quite faster and more efficient than this GUI interface. Okay, but the two component, one is Mathematica GUI interface. You put any query, it eventually going to be kernel. Kernel is going to what say compute that particular query and produce the result over back to the GUI interface. Okay, so coming back to our this slide, we are talking about the Wolfram Alpha. Alpha is basically a computational search engine. So Alpha is basically computational search engine. Okay, and it you put any query to, you give any query to Alpha engine, and it basically does a semantic interpretation, and then it tries to solve that query using the available computation method. Okay, so you can access Alpha by two ways. You can just go to any browser, available browser, and just type Wolfram Alpha, So you can also access Wolfram Alpha from there. But if you have Mathematica notebook with you, like this one, I have a Mathematica notebook or some Mathematica software with me, then I also can make an API call. Alpha basically they does an API call. Okay, it's basically an API service. Okay, so to basically call that service, I can use a Mathematica notebook. Just open a Mathematica and click anywhere on the notebook and press equals button. So this is a sign of alpha. Okay, so now how to access information with alpha? So if you want to do alpha, just remember, just put your query in simple plain English. Okay. In short, one of the most salient features of alpha is that we not need to follow any syntax. Right. So suppose if I have a query like I integrate 10 squares. Okay. So I called the alpha symbol and I put my query in simple plain English. Okay, I'm not following any syntax. This is like one of the most salient features of alpha. And I will press enter. It will contact the Wolfram research server. Okay, and then it will just try to solve the query using the computational method. So you can see here we are getting two things. So the second is integrate 10x square x. This is basically this would be look like when we have used Mathematica code. Okay, and the output is minus x plus 10x. Okay, so the best part with alpha is that you can put your query in simple plain English. Another best part is like you see all the computational softwares. Okay, they are basically designed in a manner where we give them input and they basically gives us the output. Okay, they are not designed in a manner by which we can see the backend operation, or you can say like step-by-step solution. There are some methods available in Mathematica also where you can see the backend solution. Okay, but in case of alpha, we have like step-by-step solution. So once you expand your alpha result here, you're getting there's a menu here like step-by-step solution. If you click on it, it will expand. And it is going to show you the backend steps your computational engine has used to solve this integration query. So the best part with alpha is, first of all, you don't need to follow any syntax. Second is you can actually see the backend operation. It is quite useful if you are a student or like a researcher. Because sometimes you don't need to only see the results. You also need to know like what are the backend operations that engine is using to solve a particular query. So such information can easily be accessed through Wolfram Alpha. Just put your query, evaluate your query using press enter, evaluate your query. If it gives a result, expand your result, check the step-by-step solution, and see how the engine is basically computing that particular query. Okay, so as I have told you, like you can access alpha from via two ways. First of all, by using Mathematica software, or you can also use alpha from browser. Okay, so you can do the same thing from browser. Just put your query in simple plain English, and it is going to give the result. I guess they have put some subscription on the step-by-step solution nowadays. Okay, so if you just want to unwrap this part, then you need to pay something. Okay, they have policy of changed. So, but if you have Mathematica software with it, then you can directly access alpha, and you can also check the step-by-step solution. It can take any query. It can take plot equations. It can take this like integrate equation. It can deal with differential equations. Okay, it can take anything. And I will say, if you are new with Mathematica software and you do not know how to use the Mathematica syntax properly, then you should start working with the alpha first. Okay, like in this one, it is showing like integrate 10 square x, and beneath this expression, you are getting like I integrate 10x. There is some syntactical form here. This is a syntax. This is basically Mathematical syntax. If I have put this code in the Mathematical syntax form, I would have used the same code that is showing. in this one, right? Okay, so next here is like the alpha queries. As it's basically computational circle, then you can ask other queries like what is the, it's some examples here like life expectancy in India, or like nutritional information about the food we eat, or the energy expenditure for our daily activities. You can also get like economic information about the world, or it can be used for doing some other crazy tasks like solving puzzles and exploring data about movies or something more. Okay, you can put such queries in alpha. So these are the areas that alpha covers. You can find like if you just go to YouTube, you will find many people are doing a lot of stuff with alpha. They are using the alpha capability to design their own AI engine. They will find many examples on YouTube there, right? So long story short, if you just want to start working with Mathematica and you don't know how to start, how to like what is the proper form, you don't know the syntax and other things, then in that case you can start working with the alpha. Just get Mathematica software, and in the Mathematica notebook just press equals button and put your query. Okay, and it will just replace that query with the Mathematica syntactical form. Okay, so next we have is the Mathematica syntax. Now, alpha is good if you want to access any data, okay, or if you want to start in Mathematica and you don't know what is the Mathematica syntax. In that case, alpha is good. It can deal with equations, but you see, alpha has certain limitation, especially in terms of like let's say queries, mathematical queries. Okay, it can easily handle like simple and sometimes like average computation complex queries, but in case of like advanced one, alpha doesn't provide such flexibility. Okay, in that case we need some engine which can run on like our local machines. It can be our laptop, workstation, or a server, or a like HPC computing facility. So then comes the mathematical syntax. So in Mathematica, there is basically three golden rules that one needs to remember. So if you want to start working with Mathematica, it has three rules. You just need to follow these three rules. Okay. So the first one is like Mathematica built-in function. If you're using any Mathematica inbuilt function, then their first letter should be capital. Then we have like let's say list range. Okay, so when we're invoking list, range vectors, or iterators, jumpers, then you need to put them in curly braces. Okay, so this curly braces are quite ubiquitous in Mathematica. We use in a lot of things. Okay, so you basically give any query to Mathematica, it basically give back the result in terms of a list. Okay, so we will study that part. So okay, this is the second rule: list, range, and vectors in curly braces. Then the third one is like mm, function arguments. So this is basically the three golden rules that one needs to remember while working with Mathematica. The first is like first letter should be capital. Second is like list range vector should be in curly braces. Third is like function order must be in the square brackets. Okay, I will just show you an example here. So as I type like plot here, you can see suggestion menu down here. I can get like so many things. And let's say take any function. Okay. So here we have a Mathematica code. Okay, so this interface is basically a notebook, and if we type anything in Mathematica, it basically angles into a cell. So if you just go to this right hand side, you can find there is a cell here. Okay, so if there is a code, if it is not a text or any other style format, then it will be assigned an input number. Okay, like once I execute this code, it will get an input number, and some subsequently when this code will get evaluated and produce the output, it will get an output number. Okay, so Mathematica code is basically defined by the cell on the right hand side. You can find this is the cell. Okay. So in this particular code, we are plotting a sine function from x from 0 to 2 pi. Okay, so now let's just compare this particular code with the three rules that we have stated here. So the first rule is like Mathematica built-in function first letter should be capital. Okay, now how can we know that which is Mathematica built-in function, which is Mathematica non-built-in functions, right? So in this particular code, we have plot, sine, and pi. You can see like all these functions first letter is capital, and they are appearing black in color. So if your kernel knows about a function, like kernel knows the definition of a function, in that case, it will appear black in kernel. It will appear black in color. Okay. So if you're suppose if you're constructing your own user-defined function, okay, and once you initialize those functions, they will also appear black in color. Okay. Just remember one thing: when you are creating your own user-defined function, in that case, just do not remember this first one. Okay, because sometimes what happens like you're using a function and this function may coincide or like may coincide with like Mathematica built-in function. So it's better like you put your question, if you can create your function without keeping the first letter capital. Okay, so the first rule that the function first letter should be capital. So these are the function 1, 2, 3. Their first letter is capital. Okay, second is like list range vectors in curly braces. In Mathematica, when we work with data, okay, as I've told you, you put any data to Mathematica, it's basically treated as a list. We work with matrices. You put any matrices to Mathematica, it is also basically a list of lists. Like if you're working with 3 by 3 matrix, it is basically a list of list. Okay, to your mathematical display form, when we use matrix form, it will appear like in a proper matrix way. But in actual, to my kernel knowledge, it is basically a list of lists. So if we are providing any list range, like we are giving it a range, x will run from 0 to 2 pi to 7.01. Like this is the range that I am providing here. If I'm giving any list range or curly braces, it should be under the curly brackets. These are the curly brackets. Okay, and the last one is like Mathematica function arguments must be in square braces. So to my sine, the argument is x. To my function plot, the argument is on the right hand side. Like, so suppose if we somehow miss any of this, suppose let's say first one, Mathematica built-in function first letter should be capital. Let's just replace capital P with small p. Okay, now you can see the color of plot has changed from black to blue, which means your kernel does not know the information. What is plot function? So if I do shift enter, if you want to run any query with in Mathematica, use shift enter. Okay, it is producing the, you can see this is the input number 10, this is the output number 10. So it is replicating the input and the output. Okay, because your kernel doesn't know the information of plot. What is this function? It's not basically function. To this Mathematica, it's basically a variable or a symbol. Okay, so I will just replace it with capital P. Now suppose if I remove one of the curly braces and again do the shift enter. Okay, now it is giving me an error. If I expand this one, Okay, syntactical error, expression plot sin x O to 2 pi has no closing, which means some braces is missing here. So I'll just put back the curly braces here. Now, if it follows all the three available syntax, these are like three golden rules. If I do shift enter, yeah, this is the result that I'm looking for, the plot of sin x from 0 to 2 pi. Long story short, if you want to start working with Mathematica, remember these three golden rules. Okay, and the more you practice, the more you will get more like used to these rules. Okay. Okay, there are certain other parts also. Let's check. Okay. 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 Now to Mathematica engine, as I've told you, one is Mathematica, second is the kernel. Okay, this is the GUI engine, and it follows certain rules like there is a head. Head basically tells the nature of expression, how a kernel basically takes a particular expression. Like suppose if I give any number to this head, so if I give any number to Mathematica, it's basically considered as an integer. If I just put a decimal here, this will become a real number. Okay, and if I just put a complex, okay, then this will become a complex number. Similarly, if you just give any uh, argument with under the quotes, then to your engine it becomes a string. And if you just remove the quotes from here, this will become a symbol. You can say like it will be a symbol, or it can be also treated as a function if you are supplying some arguments. Okay, so when you work with certain such data formats, like if you're working with C, you need to define the data format like int, character, so and so. In case of Mathematica, we do not need to define such data formats. Okay, you just need to remember these rules, like if it is a number, then there is integer. If there is decimal, it will be real. If it has complex, then it will be a complex number. If it is under quotes, then it can be like a, let's say, then it will be a string. If it is not under quotes, then it is basically symbol. Okay, so symbol in the sense it is a variable. Variable are used to, let's say, store definitions. It is also used to store values. It can also be function. Function also does the same thing, but function takes arguments. This is a difference between this function and the variables. Okay, the next part we have is the core of Mathematica. Mathematica core is basically a list. Okay, lists are abbreviations in Mathematica. Okay, whenever you put any data in Mathematica, it gives you the output. It gives you output in terms of list. Okay, so if you want to learn Mathematica, learn these three golden rules. Okay, learn some of this basic rules. Okay, like how your Mathematica engine is basically taking that particular expression. Okay, it can be atomic expression, it can be non-atomic expression. Okay, then comes the list. List basically so we have created a list one with numbers like 1, 2, 3, 4, 5. Okay, so list manipulation is very important in Mathematica, especially if you are designing your own functions, okay, or on algorithms. Mathematics, it is very important. Okay, Mathematics has many functions, like you can do plot, you can do simpler things. Okay, there are many functions which you can use directly in Mathematica and you can get the result. But if you just want to dive more, that in that case you just need to cover list part. Okay, so suppose like list manipulation requires like where you can basically access any list element. So suppose this is our list one. So if I just need to extract the second element, so I will use notation, or if I just need to extract the last element. Okay, similarly, I can extract element at a span. Okay, so there are many techniques under list manipulation which comes in Mathematica, and it's quite important to learn all those techniques. Okay, we do not have enough time, so that I will skip most of this part. Okay, but I will show you this one. Like one more thing, like in list you can treat as more like an array. Like in C++ or C languages we use array. They are basically containers. Okay, and array has basically indexing from 0. Like if you want to extract, suppose this is an array 1 2 3 4 5 contains 5 elements. If you want to extract the first element, then you will use like array location 0, then 1 2 3 4, so and so. Okay, in case of Mathematica, the indexing starts from number 1. So this is index 1, index 2, index 3, index 4, index 5. That's why if I just put index number 3, it will give me the third element of this list 1. You can also see this list one is appearing black in color, which means my kernel knows the definition of this symbol. Which means that there is a variable there. It has been assigned some definition. Okay, and kernel knows this definition. If I just want to clear the definition from the kernel memory, I will use clear list one. Now the color has turned to blue, which means that your kernel doesn't know the information of this variable now. Okay. Right. So yeah. Okay. So if you just want to learn more about list in Mathematica, there is an online guide like in an introduction to modern language. Okay. This is basically an online guide. You can just put it on browser and you can check. So it is basically collection of all the things or like syntactical things which are in Mathematica. Okay, so I will just recommend you, once you've gone through these 3 golden rules and some other basics, just complete this an introduction to Wolfram language. It is over like collection of 34 exercises. Okay, which basically tells you how Mathematica function work, how kernel recognizes those function, how you can use those function to do variety of other things. Okay, so you can cover this part, an introduction to Wolfram language. Okay. One more thing is I just need to cover is like function definition in Mathematica. Okay. So in Mathematica, you can basically create 2 types of function. Like one is set function, another one is like set delete function. So suppose if I have a function like cube x, it will give me the cube root. Give it like x plus 3. Okay. So this is basically a set delete function. So like if I just remove this colon, this will become a set function. If I just put a colon, this will become like a set delete function. Okay. The only difference between set and set delete is like set function, once you run that particular function, okay, it will initialize, kernel will initialize it and evaluate the function. Okay, which means some value will get stored in that function. Okay. But in case of set delete, okay, what will happen, it will just initialize the code, it will not evaluate the code. So most of the Mathematica function where you want like you want the current output should depend upon the current input, that in that case I will recommend it like you should use this set delete option. Okay, so I will just initialize this one cube. So if I just give it cube some value, it's giving me the result. Okay, if I just supply it something else, like let's say any string, okay, it is also giving me this this something. Okay, and which is an error here. Okay, because why it is giving me so, because I have put a pattern I have basically put a pattern matching symbol here, which means it can take any argument. We can put limitation here, like it should take only integers, real, or it should only take the complex numbers, or it will should only take the per se graphics object. So this mathematical list has like a lot of properties. Like here I have put in the integer data. It can also take real. Then it can also take imaginary data. It can also take graphics object. It can also take like video files. So lists are very powerful in Mathematica. So I would just recommend you to complete this guide and introduction to Wolfram language. Once this is over, when this guide is over, then you will get an idea like, how, yeah, this is how Mathematica is working with those inbuilt functions. Okay, so, okay, there's so many slides. Okay, so I'm just taking a like 5 minutes break. We will then continue after 5 minutes.
Hello, Mahendra ji. Mahendra ji, are you getting my voice? Your screen and voice is freezed.
मिस्टर महेंद्र, आपकी आवाज नहीं सुनाई दे रही है. Mr. Mehend, please check your audio. You're not audible. There is some technical issue. Let's wait for some time.
Okay, so far we have what we have covered is basically the Mathematica features, this alpha engine, and the like what are the basic programming structure of Mathematica, how we can do function, how to create functions in Mathematica, and so right. In the next slides, we are going to see like how we can use the Mathematica inbuilt functions to plot functions, to solve equations like algebraic transcendentals, okay, and nonlinear equations, okay, how we can use these functions to solve partial differential equations and so on. Okay. Okay, my voice is audible to all of you or not?
Yes, sir, you are audible.
Okay, fine. Okay, so next we have is the visualization and interactivity. One of like powerhouse of Mathematica. So before starting this one, let me just cover one more part, which is the documentation. So on the top menu, you can find there is an option, help. Just go to help and Wolfram documentation. Okay, so you can see all those features are already in your Mathematica software. So once you install the Mathematica software, whether it is a trial license or the purchase one, you are going to get all these functions. Okay. So the Mathematica software is around 4+ gigs, which means, and out of 4, 2 plus something is only dedicated to this documentation center. So you can see like how powerful this documentation is. And the best part of this documentation is that it is not written in basically a PDF format. It is basically in CDF format, which means if I'm working with any of these functions, I can just put somewhere here. Okay, I will just go to the documentation. I can choose any function. Okay, so you can see they are, these are the like function syntax, or you can function templates. Okay, so I can just take any of this code, and I can go back to my Mathematica notebook. Okay. And let me just open new one. So let me, okay, so I will just put it here. I'll paste it and shift enter to work with that code. Okay, so it's quite easy to work with the Mathematica. Just go to documentation, fetch your code, copy it and paste it here, learn how it is working. Okay, and you can edit that code also. So next we have is like visualization and interactivity. So these are the type of visuals that Mathematica supports, like 2-dimension, 3-dimension, data, temporal, charting, stats. There is also something like domain specific visuals in Mathematica. Okay, so in case of 2-dimension plotting, we have like plot. So plot is the function which is used to do a 2-dimensional plotting. Okay, and if I ask my engine, let me just go to this notebook. Okay, if I ask my engine like question mark plot, it will give me the available syntax with plot. Like plot generates a plot of f as a function of x from x minimum to x max. Okay. Similarly, the same plot is used to plot several functions. Okay, you just need to write many functions and wrap them in curly braces. As I have told you, curly braces means list basically. If you are just giving data, giving multi-functions, okay, in Mathematica, if you're giving any such thing, it will be basically engulfed in a curly bracket, okay, and it will be treated as a list to my engine. Okay, so you can find like plot, then there is you need to give the range of x from x min to x max, and there is a default step size. You can also change the default step size by just putting a question mark after x max and write something after that. Okay, so plot basically generates a plot of f as a function of x from x minimum to x max. Okay, so like here's an example of plotting sin x from x 0 to 10. There are other functions also which can do the two-dimensional plotting, like parametric plot, where we plot the coordinates over another independent variable. Okay, so this is like my x coordinate, this is my y coordinate, which is dependent on the variable t. T is running from 0 to 2 pi. You can also plot it over like non-linear axis using log plot or log plot. Okay, and the same thing, you can also put like plot real and imaginary parts. Okay, so why this part has been mentioned here, when you use any Mathematica plot function, it basically truncates the complex part. This is the like default nature. So either you just need to change the option for it, or you just to define it like in this way. Okay, or you can do one more thing. In this version 12, they have introduced a new function known as like imaginary plot. Okay, so it will consider the imaginary, or you could say the complex part. Okay, so all this function that I'm showing you right now is basically Mathematica built-in function. So suppose if you want to just plot something and you're not sure, like, yeah, I have a query, I have a function, it has some range, I just need to plot it, but I am not sure how to start working with it. Okay, so the first thing you can do is like you can just use alpha, or like a graph of sin x. Okay, so it is showing you like there is a syntax: plot sin x minus 6 to minus 6.6 to plus 6.6. Okay, this is one way of doing thing. The other way, or I can say the more convenient ways, just go to a documentation center. This one is the documentation center. Okay, here type like, yeah, I want to plot something, just type like plot. So it will show you a couple of options in here, like there is plot range, contours. Go with the first one. Okay, so this is like the powerhouse of Mathematica, the documentation. Okay, so here I can find like there are certain syntax for plot. Like I can plot f as a function, several functions with certain wrappers. I can also plot it on a geometric region. But if I'm still not sure like how to basically start with Mathematica, you can just scroll down. You can find very good examples. These are very basic examples. You can just see like, yeah, this is something. If I just go through this basic one, like this is a plot. Okay, it is showing like it is a plot of a function. It is a plot. It is a sin x, which is running x is, it is given some range like x is 0 to 6 pi. And if when I do shift enter, it is giving me that result. So if you want to learn more about Mathematica, I will recommend you cover the rules, cover the list manipulation. Once this is done, okay, and then you can directly go to this documentation part, which is available with your Mathematica copy. Okay, you can just type the function that you want to use. Okay, check for the syntax, the available syntax. Okay, then check for the examples. If you're still not sure, check for the examples, how the examples are using that particular function. Once you get a hold on this one, like there are many examples, like you can put a filling here also. Okay, or once you get a good, you can take this example. Okay, you can copy this cell, just go to right hand side, copy. You can copy this cell and paste it on your Mathematica notebook, shift enter, and you can see like how this is changing. Okay, then you can change this function parameters. Okay, and the plot is going to let's say it's going to behave accordingly. Now there are certain more things, because using this information is good, like plot sin x, I'm getting something. This is like some very basic information that I'm getting here. Sometimes I need some more meaningful information, like suppose I just need to show my result to my audience. In that case, I just need to show like inflection point, maxima, minima, or slope. Okay, or I just need to put labels on my plot. Or suppose I'm doing a let's say I'm doing so like a three-dimensional plot where I just need to show crest and trough of my surface. Okay, in that case, you can like we just need more unique. We just need to let's say extract more meaningful information out of our plot. In those cases, you just need to go through these options. So once we use any mathematical function, it basically gives us simple result. Simple result like this function is designed in a manner by which these functions are designed in a manner by which they basically works on the default properties. Okay, if you just want to interact with their property, you want to extract more information out of them, then you can use these options. So if I just go to this notebook, I will type options. So this plot functions itself over 63 options. Options like frame level, plot range functions, plot legends, plot themes, plot styles, ticks. Ticks is quite important. I basically use ticks to, like you can see, these are basically numerical information. Okay, but while we used to work with while we used to study mathematics in our textbook form, we used to get like we used to show on radian form. Okay, then in that case, I can use ticks. Okay, then there is plot legend. Legend basically gives you the like what is the current nature of your plot expression. It is very useful, especially when you are doing a dynamic plotting. Okay, then there is plot themes. Okay, then there is plot levels. Levels is also very important. Then there is one thing like okay, wait, there is. Hmm, yeah, this one is like max recursion. Okay, okay, so max recursion or max functions, these are basically more like to make your curve more smoother. Okay, I guess you all know that like whenever we plot a function, it basically takes some points and the plot basically tries to cover that point. Okay, so the same technique, the computational engines use the same technique. They basically take some like sampling points and they try to cover those sampling points sorry. Okay, so the plot will try to cover the sample points. Okay, but if you want to make your curve more smoother, okay, then you just need to increase the recursion values. Okay, increasing the recursion value also basically puts some stress on your computational resources, because now the function will use more resources to draw a smoother curve. Okay, that can also be done. And then there are like there are so many options in here. You can just like this one is epilogue. Epilogue is like putting such graphics also, like this one. These are the graphics dot in here at point 0, 3, and 6. Okay, this is like it is mentioned like point size is 0.04, then point is 00, pi 0 to pi 0. So these are the points in here. You can put such graphics object on your plot also. Okay, then there is evolution monitor. So there's many functions. Okay, the session time is quite less, so we are not able to cover this whole part. And then you can go to more deep by visiting this application section, like how you can use it in applications. Okay, like there's some basic applications followed by someone like how you can plot complex value functions. Okay, so start with Mathematica, learn basic rules, get a hold on basic rules, learn the list manipulations. Okay, once you have get an idea like how it is happening, go to documentation, fetch the function that you want to work, go through these examples. Okay, and if you just want to get more meaningful information out of it, just go through these options, use them in your codes, and get the result. Right. Similarly, there is like three-dimensional plotting. Mathematica is not just limited to what you say plot function. I will just go to this documentation part again. If I just go to the home and this is function visualization. So you can see there are like many functions in Mathematica for functional plot, log plot, plot 3-dimension, contours, okay, density plot, parametric plot, number line plot, then there is complex plot, which are available for like 2-dimension and 3-dimension both. String plot, okay. So there are many functions in Mathematica, and one doesn't need to understand all of this function. Just go to documentation on the search bar, type your query. Okay, like you just want to plot a function. So type that query, it will give you the relevant things. And like suppose I just need to plot a two-dimensional function, then I will just plot. If I just put, I just need to call any region under it, then I will use region plot. Okay. And similarly, if that plot has another, I would say, an extra dimension, then I will use a plot 3D. Like this one has an extra dimension here, y, running from -4 to 4. I will just shift enter. Okay. Similarly, I can also map this onto a two-dimensional axis, like conversion of 3D to a two-dimensional axis using the contours. And if you have ranges, which is in, if you have spherical coordinates, then there is spherical plot. If you have revolution axis, then there is like a revolution plot. So you see, there are many functions in Mathematica to do plotting. Okay, this one is example data visualization, which will list out the first 25 prime numbers. Okay, so there are other examples of like this charting visualization. This one is a bar chart. Similarly, there is a statistical visualization. Okay, so you can find all these examples in the documentation center. And there are some more, like you can also customize your visualization. Like let me show this one, surface leveling. Okay, like in this result, what I will going to show to my audience is that this is my plot result, and it is also giving me like maxima and minima point, which means it is giving me more meaningful. It is what's it? It is extracting more meaningful result out of my plot. Getting a plot is one thing. Getting meaningful result out of plot is another level. Okay, I will just show you the code here. So first of all, what we are trying to achieve, we will find the maximum value and the minimum value. Once this is done, as our plot has 3 axes, so I will use 2 axes to by using plot 3D. Plot 3D will put this expression. Okay, I will use certain other functions like call out or so to put our max and minima on my plot function. Okay. Okay. Next, I just want to introduce one more function which is used to do dynamic plotting, because we have seen many examples of dynamic plotting so far. So the function we use is basically known as manipulate. Manipulate basically generates a version of expression with some controls. Okay. It basically, suppose if you have an expression, it basically creates a control. It creates a, first of all, it creates a point. From that point, it will control your expression, which means your control definition is going to change when that point is according to the point range is changing. Your control, you ever say your expression definition is also changing. Okay, so suppose if we have the same example, plot sin x, I will add like frequency in here. So I will manipulate my function over frequency. Let's say my frequency will run from 1 to 10. Okay, then I will just yeah, the last rule, the function argument must be enclosed under square brackets, manipulate. Okay, so adding a point whereby which I can basically play with my definition, my sign definition, the trigonometric definition. Okay, so if I change this slider value, my plot result is going to change accordingly. Okay, I can add more parameters like amplitude, phase. Okay, and similarly I can add an option in here like plot legends. Okay. Please keep yourself muted. Okay, so I've added an option plot legend, so which means now if I change my result is changing, my definition is also changing accordingly, and I can see my definition like this one is rapidly changing. So this one is known as dynamic evaluation. Okay, once you are getting static evaluation, and then there is dynamic evaluation where the current output purely depends upon the current input. So manipulate is widely used in many examples, not in dynamic plotting. It can also be used in mathematical expressions, especially in during the power series generation, or if you are just want to solve an equation over a set of values. Suppose you have an equation, right? And you want to solve it for a set of values, and you don't want to code again and again for different values. Then you can just use manipulate function. Okay, put it at a point where you can basically control your function definition, and give it some range with some step. Okay, and it's going to interact with your definition accordingly. Like here we have some other examples. This one is like nested three-dimensional structure. Okay, so if I just reduce the opacity, I can see inside my plot. If I increase opacity, yeah, this one is like a solid diagram now. Or you can create like some funny string examples. If you just go to Mathematica website, there are people who have created many logos, very like animated logos using this manipulate functions. Okay, they're also using a couple of other functions. It's not just manipulate, but you can just take their code, edit it, and you can also create such things. Okay, this one is example like three-dimensional volume texture slicing from a two-dimensional CAT scan is like a collection of two-dimensional CAT scan, and putting it on a same scale to let's say produce a three-dimensional skull figure. Okay, so next we have is the mathematics and statistics. So this one is basically an symbolic and numeric computational engine. So most of the function that we are going to cover, as we do not have much time, so we will just cover the symbolic part. Okay, so we start with the function solve. Solve is a method inbuilt function which basically work with this system of equations. Okay, you can use solve to solve the equation, any order like quadratic equation or like any order equation. You can also use this solve to solve equation. Suppose you use equation like two-line equation or like a circle or parabolic equation, you can use the solve to solve it. Okay, and you can find more meaningful examples in documentation in here. So solve just need an expression and for the variables over which you are solving the equation. Okay. One noticeable part in Mathematica is that how you define a function. Okay, so suppose I have a quadratic equation like ax square. Okay, so if I just put ax square in Mathematica, what will happen? It will become a symbol. It will not treat this expression like a multiply x square. It will just treat it as a symbol like ax square. That's it. Okay, so you can put a space between those two characters, which means a space means a multiplication operator has been called here, and now it is basically a multiply x square. Okay, similarly I will use plus bx plus c equals 0. Now what is happening here? In case of Mathematica, there are certain rules while defining your what's it functions and queries. Okay, so suppose if you are defining your expression and if you use equals, so equals is basically an assignment operator in Mathematica, which means whatever thing is on right hand side, it will get assigned to the left hand side symbol or function. It's basically an assignment operator. So to my engine, this will not be an equation. This will basically become an assignment operator. Right hand side, whatever thing is the right hand side is basically be assigned to the left hand side. symbol. Okay. Suppose if I just say like a, suppose 2 equals 2. Suppose 2 equals 2. Okay. So it is saying you cannot assign the raw object to 2 because 2 is already a defined numeral. Okay. So I cannot assign 2 to it. Okay. I can just replace 2 with any symbol. Then I can do the necessary assignment. Similarly, if I just put 2 double equals 2. Now to the mathematics is basically an expression which is like LHS is equals to RHS. Okay, it is not what's it in the first example what is happening with a single equals, right hand side is getting assigned to the left hand side. Now what is happening, the LHS is equals to RHS. This has become an equation. So it is saying like 2 is 2 is equals to 2. Yes, they are basically equal. We just put 2 by 2. No, they are not equal. This has become like this is now becoming Boolean expression in here. Similarly, if you're defining any function in Mathematica, we'll just replace equals small equals to double equals, which means now this is like equation LHS is equals to RHS. I'll put X, and according to my solve definition, it will enclose the function arguments with square brackets. Solve. Okay. So once I do the shift enter, I'm going and getting the result, okay, of ax squared plus bx plus c. You can see the result is basically in list of list. Okay. So as I've told you, you give any data to Mathematica or you get any output from the software, it's basically put it under list. You can apply rules to a variable to extract out the information. Suppose like if I just want the first one, so I can use this one, or similarly I can also extract the second one. So here in this case, that's why the list manipulation becomes quite important. Okay, now back to our presentation slide. So here are some other examples, like we are finding intersection point of circle and parabola. Okay, so what we are trying to achieve, we are solving, first of all we are solving these two equations. Once we solve it, we are getting some intersection points, coordinates basically. We are using the contours and show to combine those graphics in here. You can also use solve over a three-dimensional region. Like in this one, these are like, this is basically a sphere and infinite plane, and we have a function in here. So we are just getting like the points where these three figures are intersecting. They're basically four coordinates, 1, 2, 3, 4. Okay, so it is also linear algebra. For linear algebra, it has like linear solve function. There are many other functions for you can also get like determinant or eigenvalues, eigenmatrix. Okay, you can just go to this documentation again. You can find it under matrix and linear algebra. You can find all these functions in here. Okay, so next we have is basically calculus. In case of Mathematica, if you just want to invoke any differential operator, we use this notation. We just go to this new notebook, capital D. Okay, so this capital D is basically a differential or something like partial derivative in Mathematica. Suppose I just want the derivative of sine x, x2. Okay. So this is the derivative of sine x. Okay, it is basically doing the 2 times derivation of this expression. So first of all, it will derive it, then it will again derive the output that it is that you are getting. Okay, so this is basically a mathematical syntax form. I have seen like I've been interacting with many people, especially people who are working in Mathematica on their research, and I find that sometimes they are unable to see like how Mathematica syntax is working. Okay, because we are all used to our mathematical textbook form. We know how expression are working there. Okay, so similarly, if you just need to know like how this expression are working here also, just go to this cell and you can convert it to traditional form. Now you can see this form. This is basically the form that we used to use in our textbook. Similarly, if you are still not more convenient with this functions, then you can go to palettes, basic math assistant, and you can choose these available options. There is also option for integrals, like this one is indefinite, this one is definite. You can also take like submission operator here, so you can invoke like superscript, subscript. Okay, so but I will just say, like, once you start working with Mathematica and get more used to the software, people generally will not use this palettes. They basically use more shortcut notations. Okay, now back to our presentation. Like this one is a integration of highly oscillating function. You can try to solve this equation, this one, using the conventional method. Okay, but due to this highly oscillatory nature, okay, most of the people will not be able to find the solution. Okay, so the trick here is that just map this expression onto some other integrals. Like you can use contour integrals here to solve this expression. This is basically science challenge problem. It is quite famous one. Okay. So yeah, you can also do optimization thing in Mathematica. So it is like you can optimize over using like and minimize and maximize, which use global based optimization. You can also get nonlinear constant and constant optimization. Okay. Like here, what we are doing here in this one, our job here is to find the multiple minima points, and in my code I am just restricting myself to point 10, as this is one is a locus. It must have a collection of infinite points. I'm using contour to showcase onto my two-dimensional plot. Okay, so next we have is protein statistics, complete package in Mathematica. Okay, the another powerhouse of Mathematica, differential equations. It can deal both with symbolic and numeric differential equations. Especially in case of symbolic, we use Andy solve, and is in case of numerics, we use sorry, symbolic we use D solve. For numeric, we use Andy solve equation. So like this one is an example of Lorentz attractor. Okay, these are some other example. Like this one is another famous example. Is basically a Lotka-Volta delay model, which basically depicts the interaction of two species on a certain biological environment, and it basically works on certain assumption. Like so, one is predator, second is prey. So the assumption is like prey is in large amount, and predator food is directly proportional to the population of prey. Okay, so once predator starts attacking prey, their population starts reducing, and after some time the food will become scarce. Okay, because yeah, the prey count has gone down, which means very less food for predator. Now as food is less, which means predator will fight among themselves. Okay, and their fungicides are basically sometimes more brutal and can cause death, which results in less predator population. So due to this less predator population, it gives some time to prey to reproduce again, and their population will again shoots up. So by this model basically balance out each other. Both species basically balance out each other. Okay, so this is the like Lotka-Volta delay model. We are using here Andy solve. So this model, this one is like where there is no delay, and when delay is introduced, you can see with delay you can see more spikes in here. Right. Okay, this one is a wavelet example. I will just show you the short on what is happening here. So we have a noisy data. We put the wavelet transformation technique. Then we filtered out the wavelet, or say the noisy part here. This one is the noisy part. apply the inverse Fourier transformation to get back the original signal. So you can see the overall effect. So the left hand side is the signal with noise, the right hand side is the signal without noise. Okay. Import formats. Okay, so these are the import formats that Mathematica supports. So if you're working on any of the such data formats, you can import them in Mathematica using the command import. Then you just need a file path, insert file path. Okay. So in case of Windows, you use the same technique. In case of Linux or Macintosh, the same technique is there. There is insert file path. You can import file in here, assign some symbol to it, and you can start working with your file. Similarly, if you are doing like research publication with Mathematica, like this software is used for teaching purpose. People are using it for doing course related issue. People are also using it for like research work thing. Then you can do all your thing, like you can put abstract here, you can type your code, you can put your equations. Once all the things has been done, you can go to file, you can use save as tech. This is tech is also available here, like export formats that Mathematica supports. So far what we have seen in this session is basically the features of Mathematica, the alpha engine, how we can use it, the mathematics syntax, how to plot it in Mathematica, how we can solve mathematical queries in Mathematica. Okay, and you just go through all of these functions which you want to use or which is related to your queries. Okay, check it through documentation and start working with Mathematica. Okay, then we have like there are many other things, but okay, this is something like parallelization GP programming, although it is quite advanced level because in small codes you don't need parallelization, and I can say like most Mathematica inbuilt function are basically parallel in their own. Okay, but sometimes once if your resource code is taking too much time, you can use uh, the more amount of local resources available. In that case, you can uh, implement the parallel functions in Mathematica. So Mathematica is already inbuilt parallel function. It is also the function which uses parallel capability in on their own. Okay, like here we are using parallel evaluate. Okay. So let me just initialize this one. Like first clear the function, run the code. So it is launching 4 kernels. There are 4 cores in my system. If I just put this query on a single core machine, it will take some time. Okay, it is running. So it is taken like 5.12 seconds. If I just put it on 4 core machine, it is taking 2.12 seconds. Okay, so difference is quite small, but you see this code is also small. If you are running with big queries, these things are quite useful. Okay. Now there's certain things that I just want to show you. Just how to share this one. Share screen. Okay. So these are some fantastic websites by Mathematica. So first one is like demonstration.wolfram.com. It is basically the collection of all Mathematica based projects. And you can basically go to demonstration.wolfram.com and you can type the relevant project that you're working on. Suppose like if I'm working on differential equation. Okay. So you can find there's many projects.
तो पूरा है
Okay, so there are many projects available here. So if you have Mathematica, you can basically go to any of this project and you can download their source code.
ये वाला ये वाला ना ये तो ये रख पड़ेगा एक से
Hello. Okay. So you can go to demonstration.wolfram.com, or so you can also access Mathematica using the cloud facility, www.wolframcloud.com. You can sign in here. So you need a Wolfram ID. It can be your email ID, and then you need to create a password. Once this is done, you can also sign in here. So Mathematica Cloud is the same as Mathematica desktop version. Okay, you can do the same computation things, but it will be run on a cloud engine basically. And this is your Wolfram Alpha. www.wolframalpha.com, the API service. Then there are also certain like Wolfram technological books here. So these are also available. So and there is also community of Mathematica. So if you have any queries, you can directly put here. So I guess I have covered some topics so far which are good to go for this session. So now we can go with some queries if you have. So if you have any query, you can ask me.
Hello, yeah, sir. Very nice, very informative lecture, and it gives us very deep insights that we generally encounter while interacting with Mathematica. Now it's time to take some questions from our esteemed participants. Now I am reading out the questions from the Zoom chat box. The first question is, sir, can you hear me?
Sorry, you are not audible.
Hello.
Hello. Yes, sir. Yeah. Continue.
Yeah, sir. So the first question is from our participant, Dr. Ananya Tripathi. She's asking, how can we collect the coefficients of a non-linear term in Mathematica, especially in partial differential equations, when we are encountering these partial differential equations?
Okay, fine. Okay, can you share the example here? Hello? Is it possible you to share the example?
So she has shared some question that suppose we are dealing some partial differential equation and
Yes, sir. Yeah.
So we need to take out the coefficient of some non-linear term in that equation. So
as I have not seen that particular query, I will just list like there is a function known as coefficient list or collect coefficient if I'm correct.
ये अनम्यूट ही नहीं हो रहा यार इस पे पता नहीं क्या बीमारी हो गई आज नहीं देख उसको आराम से बट मैं नहीं कर रहा ये तो मोटा थैंक बोला तो बस ये करवा
इंद्री मैम आपकी आवाज मेरे तक पहुंच पा रही है
Okay, so you should see actually I'm getting a lot of noise.
मैं अपने पे क्यों लगाऊं भाई मेरा काम चल रहा है उस पे लगा लो मैकबुक पे यहाँ पे व्हाट्सएपिंग चल रही है इस पे मैं बोल रहा हूँ इस पे जूम खोल लो
इससे बोल पाऊंगी मैं
नहीं
ये कहां चलेगा ये
वैसे बोल रहे हैं फोन पे बात करती हो
नहीं उस पे
ये नहीं चलेगा वो नहीं चलेगा
उसने बोला है कि मैडम फोन पे खोल रखा होगा तो नहीं चलेगा हां हेलो हां अच्छा ओहो तो ये अनम्यूट क्यों शो कर रहा है यहां पर अरे ये यहाँ नहीं, but it is showing unmute on my screen. But what is happening on, I don't know. क्या ये लैपटॉप ही अटक गया.
Hello.
Arindri ma'am, please log in from the one system. You are logging with the two systems.
No, I have not on the mobile.
Yes, it is shown that you are logging with the two systems, and one is unmuted and one is muted.
Hello. Yes, sir. Can we start now?
Yes, sure.
Yeah.
So, okay,
Yeah.
so as I have not seen that particular example, so in Mathematica there is basically a function known as a coefficient list where we can collect coefficient in terms of a particular expression. Okay, so I guess you can use this particular function to collect the expression in nonlinear PD. Okay, but if you're still not sure, like let's say, if you're still not sure like how to use it in your equation, then I will recommend one thing. You can just simply drop a mail to me. I guess you can see this is my this is our company support ID, or you can directly mail to me at, and you can use support or mahindraestimate.com. So just remember one thing: if you're sharing me your query, just give me just concrete and precise information.
Okay. Thank you, sir. I hope Ananya must have cleared her doubt. Now, the second question is from Bhavesh Malhotra and Dr. Bhavika Panjal. They are asking that there are some similar softwares that MATLAB or Python. Then why do we prefer, or we should prefer, or we should use this Mathematica over these softwares? Is there any benefit, or what do you say?
Okay, so this question is basically I have done many workshops and webinars, and people used to ask me such things. Okay, you see, Mathematica, as I say, I am working with many. I have worked with many other softwares, and I will say that those softwares are also quite fantastic. Okay, but you see the software structure. Suppose like Mathematica is functional in nature. Functional in the sense, suppose if I want to plot an equation, I will just use plot. I will put my expression. I will give it a range. It will plot it. It's the same thing if I want to do in MATLAB. MATLAB is not functional in nature. It's basically C-oriented language. Okay, you just need to build a base. Then you can call. Then you just need to call it for the function. Then you can produce a result. Similarly, if I will say that if you are getting an engine which is knowledge based, the Mathematica has function which knows a lot of things. You just need to learn the syntax there and how to use them. Okay, so what is harm in it? This is very easiest way of doing things. Yeah, people say that yeah we can use other language. I will say things like there are many ways of doing same thing. Some people use functions, some people will create from base calling other libraries, some people do other stuff. Okay, so if already they are established libraries, then why just need to create a new one? Because our goal is to get result, our goal is to teach our student, right? So in that case, the mathematics is more, would say, more flexible. MATLAB is also a fantastic language. Okay, because I used MATLAB during my engineering days. Okay, and but I will find like Mathematica provides more meaningful information and it is quite easy to work. It's not like I just need to spend my most of the time learning the language, then I can start working with. And Mathematica, just remember the three rules. Go to learn some list manipulation, and you can start working with it.
Thank you, sir. Sir, the next question is from Dr. Rubina. She's a botanist, and she's asking what can be the applications of this mathematical software in biology in her field.
Okay, in biology, okay, actually, I'm not sure the application of mathematics and biology, but I will just say that, in our, let's say, in our communities, there are some people who are from chemistry background. Okay, you can take an example from this one. Like they use mathematics because like they are working with lots of equations, which are basically they are working with partial differentiation PD equation they are working with. Okay, so they use Mathematica. Okay, so when I ask them why they use Mathematica, they say basically we have PD equation and we find Mathematica quite useful in solving such equation. Okay, so if in biology you have something like you are plotting some, like in biology also because I don't know about this field, if you're plotting some function or if you're working some any mathematical queries, then you can use Mathematica.
Okay, sir. So the next question is from Dr. Harsha Kharbanda. They are asking how can we plot bifurcation diagrams for continuous systems? For example, consider any Lorentz system or any other system.
The Lorentz attractor that I have shown you.
Okay.
In this slide, I have shown a Lorentz attractor. And there is also a bifurcation diagram there.
Okay, sir.
You can just ask just ask that particular user that he can basically directly communicate with me on my email address. Okay,
sure.
Then I can give him the relevant examples.
Okay, sure, sir. Sir, the participants are also asking for this your PowerPoint presentation. They are asking to share
this PowerPoint presentation. Okay, I will share you some of this as these are basically more like company material. Okay, so I will share you some resources. Okay, you can go through those because most of these slides, it has basically some basics and some advanced combination. Okay, and the resource that I'm going to share you, it's basically only for the mathematics student. Okay, like in this slide you can find I have things for image processing, then I have things like wavelet analysis. There is also control system designing. Then I have also mentioned system level designing. So it is not required. So I will just share you the points which is to be used by mathematics people.
Sure, sir. Sure. It will be really kind of. Okay,
I will share Google Drive link with you all.
Okay, thank you.
Or whoever the concerned person is.
Yeah, sure, sir. Sir, the next question is from Dr. Amarpreet Kaur ma'am. She's asking, can you please explain how to get the palettes option in Wolfram Cloud?
Wolfram Cloud. Okay. Wait. Actually, I do not use Mathematica Cloud too much. Okay, so I can't answer this question right now, but I will do one thing. I will just ask my CS team, where this palette option is, whether this palette option is available on cloud or not. Okay, I do not use the cloud anymore. I have Mathematica like local copy, so I don't go on cloud anymore.
Okay. So the next question is from Dr. Sumit Kumar. He's asking that does Mathematica software support distributed computing, that is for network distributed processing?
Sorry, support
the distributed computing, that is for network distributed processing?
Not exactly.
Computing, yeah.
Not exactly. Can she basically explain more, like what she's looking for? Can you get more data?
For network distributed processing.
Your voice is very, very low.
Yeah, sir. He's asking for network distributed processing.
Network is okay. Oh, that is not in mathematics.
Okay. Sir, the next question is from Dr. Bhavesh Malhotra. Does Mathematica have cellular automation built-in algorithm?
Which
one? Do you
one?
have any built-in algorithm in Mathematica for cellular automata?
Cellular automata. Just ask that user to search in documentation. Okay, if there is a method, you see, if there is a method, and if it is in Mathematica, then he or she can find it in documentation. If it is listed there, which means it is in Mathematica. Otherwise, it will not be available in Mathematica.
Okay, sir. Now, sir, the rest of the questions will be asked by our colleague, Dr. Parveen Baba. Now, I am handing over to her, Dr. Parveen. Now it's over to you.
Hello, sir. Thank you, sir, for your great session. Sir, now there are some questions from our YouTube channel also. There is one participant, Dr. Thota Siva. She wants to ask how to generate a data form 3D plot using Mathematica.
Okay, so there is a function called list list line plot 3D. Wait. Okay, so there is a function called list plot 3D. Okay, they can use it.
Okay, sir. So your screen is not visible.
Oh, wait. Oh, okay, wait. So this is. Okay, so this one, the list plot 3D.
Okay, sir. So next question is from Khushi Jain. She wants to ask, why do we use list in Mathematica?
Why we use list in Mathematica?
Yeah.
Right.
Yes, sir.
See, Mathematica base structure is built on top of list. Like every programming language has a base structure. Similarly, in Mathematica, like I have shown you during the session, like we are solving quadratic equation ax square plus bx plus c, right? And we get the roots. We didn't get the root in simple terms. We are basically getting roots in terms of list of list. Okay. So Mathematica, whenever we give any expression, it basically puts it under list. This is like the basic base of Mathematica. That is why once you start working with Mathematica, and if you just want to create your own algorithms in Mathematica, learning list manipulation becomes quite important.
Okay, sir. So next question is from a participant Jason. He wants to ask, do we have inbuilt functions for bisection and Newton method for solving nonlinear equations?
Yes, we have.
Okay, sir. So next question is from Khushi Jain. She wants to ask why you have used log twice in the graph of x square, and what will happen if we simply write plot?
Okay, if we just simply write plot, you see plot basically puts things on a linear scale. Okay, that's example was I just want to show you that we can also put things on over a non-linear scale. Long story short, if you just want to, like, I have used many function, and if you're not clear like why I have used those function, okay, you can I guess this is available on YouTube also. Okay, so you can just take that function, check in documentation what is the function definition, like log plot, why I have used, why I'm using contours, why I have used manipulate, there is function.
Okay, sir. So next question is from participant Pradeep Kumar. He wants to ask, can we apply Mathematica software in humanity or social science subject also?
Humanity and social sciences. Okay, like I guess you all can see my screen, right? So if I just go to documentation, then like what type of application he requires. It's not about like you can apply Mathematica and everything. It's like what is your requirement?
Okay, sir.
Does he want to plot some? Does he want to import some data? Like suppose I don't know about this field. Suppose like if he was just want to call some economic data and plot it and just want to see like how it is changing over the period of time. Okay, so it's just a requirement. If your requirement fits the software, then you can use it.
Okay, sir. Okay. Sir, that's all with the query session. Thank you, sir, for your deep insight about Mathematica. Sir, now I am handing over to Dr. Usha, ma'am. So, ma'am, please continue.
Thank you, Praveen. Thank you, sir, for such a wonderful and awesome and enriching presentation. We thoroughly enjoyed your presentation. Now I request any other question. If you have any other question, participants or attendees, please drop it in the chat box. And I think Rohit, can you go through the chat box once again? I think someone has written more question. Just see, or we can then switch over the next time on the agenda. Rohit, am I audible? Anyways, so no more question. Now I request Dr. Harindri Chaudhary to please present a formal vote of thanks. Over to Harindri Chaudhary. Harindri ma'am. Anyways, sir, we appreciate your presentation, your way of explaining everything, and we are grateful to you for giving us your prize time and accepting our invitation. We thoroughly enjoyed your presentation, and I hope all the questions, all the queries have been addressed properly. Now, before we wrap up, I request all of you, sir, will you please stop sharing your screen, because I have to share the screen for
Okay.
Janagana National Anthem.
Sure.
Okay, so before we wrap up, we have to stand for National Anthem. So let's play this National Anthem. I think, sir, wait a minute. Once again, I thank all the attendees and our guest of honor today, Mr. Mahendra Singh Bish, for joining us and, of course, explaining everything of Mathematica in a very wide form. And now, seeing you next time also, as our principal has requested you to give us more sessions on Mathematica like this. So we are looking forward for that. Now, here we conclude the session, and thank you everyone for joining us. It's over.
Thank you, everyone.
So now it's the time to conclude.
Okay, thank you for attending this session. Thank you all.
Thank you, sir. Thank you very much for joining us. So I think feedback form has been dropped, link has been shared in the chat window. Please fill up feedback form. And it is all for today. We can wrap up here. Chandrasekhar? Chandrasekhar? Is there anything else you want to take up?
Yes, ma'am.
Or we can just conclude now.
Hello. Yes, ma'am. आवाज आ रही मेरी?
अब वो हरिंद्री मैम तो मैंने इनवाइट भी किया था, उन्होंने
हरिंद्री मैम इज नॉट देयर।
हरिंद्री मैम को भी इनवाइट किया था, वो नहीं मिली तो फिर मैंने रैप अप कर दिया थोड़ा सा फुल।
हाँ
ठीक है ना, नाउ वी कैन रैप अप।
हाँ ओके मैम, ओके। Okay, thank you very much to all participants and the all members of Department of Mathematics. A special thanks to Dr. Principal Dr. Raju Agrawal, as well as the convener of the event, Dr. Harindri Chaudhary, and a special thanks to all my younger colleagues. In this time, all they are in my college, basically in Deshbandhu College. So in this event, basically we have done a lot of effort. So more than 300 participants had participated in present event. I will also thanks to Dr. Usha Arora, madam. Always she works with the Department of Mathematics. So I hope, as our principal sir says, more than 2 or 3 FDPs related to Mathematica we have done in future. So basically Mathematica and MATLAB, there is a lot of questions related to these two software. So most of the queries will be sort out it. But in future हम कोशिश करेंगे कि आने वाले समय में जितने भी और जो वर्कशॉप हों इससे हमारे पार्टिसिपेंट्स को और ज़्यादा सॉल्यूशन मिल पाए। इन सब वर्ड्स के साथ मैं सभी का हार्दिक आभार और धन्यवाद करता हूँ। मैं आल्सो उषा मैम से रिक्वेस्ट करूँगा कि मैम नेशनल एंथम के साथ हम इस प्रोग्राम का अंत करें। ओके, थैंक यू मैम।